Hello everybody and welcome to the U Waterloo Games Institute Jam or Game Jam, the theme being World. In this tutorial I'll talk about the world of science and how we can use Unreal Engine for scientific discovery and innovation. So let's just jump right in. So when we're doing science, we're often lazy. We don't want to make things from scratch. We want to build upon the previous work of others. In a sense, we want to stand on the shoulders of giants. So I'm going to stand on the shoulders of the giants who made Cardinal Menu. So Cardinal Menu is a project you can Google and download and use in your projects, or use as the template for your projects to have multiplayer functionality, among other things. And so you don't have to start from the bare bones, and you can make a little bit more progress in a hackathon and do something actually innovative. So for this particular example, we're looking at Unreal Engine 4.22.2 release. You're going to have to head over to GitHub/Epic Games/Unreal Engine. You'll have to sign up as a developer. But you're also welcome to use the binaries that are available through the Epic Games launcher, so you could just download and launch the game like this. But I'm going to go into the nitty-gritty of it. So when you download the Unreal Engine 4.22.2 release, you're going to unzip it, you're going to run the setup file, it's going to set up a bunch of stuff, it's going to take a while. Then you're going to run a batch file, the generate project files, and that will generate for you a solution, UE4.solution file. You have to make sure you have Unreal Engine installed. But once we have that, we'll be able to open up the project here. Just give it a moment, and we'll see how we can get started with the engine. So make sure that things are kind of properly set up here. Development editor. We right-click over here, and we build. And this might take anywhere from 10 to 40 minutes, sometimes even an hour and a half. But when that's done, we'll be able to head over to our project. Now, for the project, as that's setting up, I've gone ahead and downloaded the Cardinal Menu project version 4.21. Unzip that into the root directory of the engine. And when you download it the first time, it's not going to have the binary file, it's not going to have these files, or rather these folders. But you will have to make some changes. I'll provide a link to this. The Varest and Victory plugins, you'll have to grab updated versions. Now, even the Gamepad UMG plugin, which allows us to have cursor control, is going to have to undergo some modifications. But basically, we're just going to delete Victory and Varest, and we're going to use the Varest and Victory plugins, which are designed for 4.22 version of the engine. Now, when we head over back to the solution file, we can see, oh look, it did build. I will head over back to the root directory of the engine, and I'm just going to make sure that I double click and generate the project files, which will update the solution file, hey Quark, which will update the solution file to include the Unreal Engine 4 project. Now, you can see we're going to get some errors here. Don't worry about that. Actually, just warnings rather. And it's going to say upload or update your solution. Oh no, there was some problem. So we just reload that. No problem there. And then we're going to select from the games menu here. We're going to make sure that we select Cardinal Menu, but we have to make sure that there's a particular setting set properly. And this will this has to be set properly, otherwise it's going to take a very long time to do things. So we're just going to head over here and we're going to select the Cardinal Menu project, and we're going to make sure it's set to development, and then we right click on that and we want to build that as well. So that's going to take a while. Again, through the magic of television, you're not going to have that. Don't worry about these warnings here. If you're particularly worried, I would look into it, but in our particular case, everything's fine and dandy. So we head over to the launcher, and we can open up that project. So project is going to load up. It's going to say something, oh, it wasn't designed for 4.21. Yours will say 4.22 because I just modified the source file for the engine. So I'm going to click yes. It's going to load up the engine and everything. So we're just going to close these other options here. So you can see the project is loading. And we're going to take a look at a few components here to see if we can actually get a better understanding of how to use this for some of our scientific work if you have a scientific project in mind. Unfortunately, I'm fighting a little bit of a cold, so you have to excuse some of the sniffling. So you can see that the menu shows up like this. Don't restore. So in your particular project, when it loads up, it probably won't have any of that stuff there. But we're just going to select level, and we're going to see, oh, there's a main menu, there's all these other components. It's a little confusing at first, perhaps using Unreal Engine. It's a bit daunting. It's kind of like sitting down at the space shuttle. But it's okay. People have made it to the moon and back. We'll be able to do this just fine. So we click on standalone game. The error or the warning shows up again. We don't worry about that. And it's just going to show up, or it's going to load the game. Whew, that's loud. So it's going to load up the game here and let us see what this game is all about. So as you can see, okay, so it loads up. You can see there's options to play, settings, about, and so on. If you want to really have your stuff be polished, this is what you can look at. So we're going to look at the particular case where we have host a game, and we have example and optical flow. So in normal example, when it loads, you just have your character running around. But we want to look at the other mode, where we're going to look at exactly what it is that we're doing in the neuroscience lab. In the neuroscience lab, we're trying to understand optical flow and how it relates to visual and vestibular integration of the senses. So vestibular is kind of like your inner ear. It tells you kind of about the balance, tells you about momentum. And how does that relate to how we perceive motion using our eyes? Fighting a little bit of a cold, so it's a little bit tough here. What you're going to see is a few options here, but we're going to look at something particularly unique to Unreal Engine, which is visual scripting. Visual scripting allows you to prototype things a little bit faster, and if NASA uses it for building stuff with Unreal Engine, then perhaps it does make sense to sometimes code things visually because you can do things a little bit faster. So we're going to look at that here, and we're going to say open up this blueprint, or as you would call it in programming, it's just a class. And we're going to see what the heck is going on here. So in particular with this project here, neuroscience, we want to look at trajectories based on angles. And we're going to look at some sine, cosine stuff, and we're going to look at how we can do random without replacement. Now, zooming in here without replacement, you can see I have this red node here, this box here. It says enter. That corresponds to the enter key, which is an event. So I right click enter, and you can see if I hover over here, events for when the enter key is pressed or released. So that's exactly what we have there. We have a path for when it's pressed, and then we have a path for when it's released. So when it's pressed, we're going to pick from random integer in the range from 0 to 3 because there are 4 values, 0, 1, 2, 3, 2.5 degrees, 5 degrees, 10 degrees, 20 degrees. We take that value that was chosen at random when we pressed enter, and we set it to a variable so we can hold on to it to do some stuff later. Now we take that random integer and we grab one of these entries from the array called trajectory without replacement, and we grab that element. So we can drag off of the array and say get array, and you can see get a ref as in a reference to the item at that particular index, And so we can drag over our integer, and then we're grabbing that particular element. So we take that element, and again, we set it to a variable so we can keep track of these things, and it's the trajectory trial without replacement, which corresponds to the trajectory without replacement array. So that's the particular element. It's a variable, and in this case, the quantity is an array, and you can see that we can change that in here by selecting these different components. Now, for debugging purposes, if you have something that you're doing that's unique, that's novel, you want to make sure you're checking your stuff. So development only, you want to print that string and see if it's the correct value. Then we go through and we do something called a for each loop for each array. So for each element in this array, we're going to check if that particular element corresponds to the trajectory that we previously selected out of the original trajectory without replacement. Now, we have another array here. These arrays are the same. The trajectory trials angles, and the trajectory without replacement are the same arrays. We're just using one to delete elements out of the other, and that way we can do this kind of random selection. So we have a trajectory trial angle, it's array. We look at each of those elements and we see if they're equal to that particular element that we picked at random from our first array, and we see when it's equal. When it's equal, so we have a branch, we drag off here on the execution, and we say branch. So that's what that element is right there. So we have this branch, and we see when it's true, we want to remove that element from that array. From which array? The first one, the one that says without replacement. So we want to remove elements from that first array and see if they're equal to the element that we selected. So if this array corresponds to that element, we want to remove things from the first array, and that allows us to have one array be kind of the temporary holder and the other one is kind of the reference. So if it's false, we're just going to print out false. But if it's true, we're going to remove that element, and then we're also going to print off the string. But there's another catch here. So when we release, now this is where those variables come in handy. We take that trajectory trial without replacement, that variable that we had here, and we say when it's not equal to 0. Why would you say not equal to 0? Because that's what happens when you remove things from an array. The existing element in that part of the array is 0. So when we look at non-zero values of the array, and we're only looking if that's true, we're never concerned with when it's false, we're just going to print off that value just so we can keep track. Now, sine, cosine, sine, 3.14159, SOHCAHTOA, most of you know, we have coordinate systems in Unreal Engine that is x in the forward direction, y to the right, z upwards. And so we're going to look at these components as being trajectories, where if I take a hypotenuse of length 8 and I want to find the corresponding x and y components, we're going to look at the cosine for the forward direction, and we're going to look at the sine as being the off angle, or the side coordinate. And we're going to make that into a vector. So here you can see it's cos d. What's cos d? Well, there's many kinds of cosine functions you can have in Unreal Engine. There's one for degrees and one for radians. So depending on how you wrote in your trajectories, you might want to be mindful of that, but in our particular case, we're using degrees, so we compute the degrees of that particular trajectory using the cosine of degrees function. We multiply that by our hypotenuse, and we make a vector, and we print out that vector and append it to the print string here, so we can see what our trajectory is. So now when we head over to our new world example, I'm just going to select Plane Editor, new editor window, and I'm just going to make sure that we can, what is this? So let me just make sure that I can make this a little bit bigger so you can all see that. So I'm going to make sure that I keep track of things, and one way you can do that is by monitoring variables in the console, where a lot of things show up. You can also make them print off in the main screen. That's kind of why we did the print string things. But if you didn't want to do that, you could still keep track of variables here. So what happens when I press enter? Okay, here we go. So we have our values here. It's 2.5, true, false, false, false. 2.5, and that corresponding trigonometry calculated coordinate is 7.992 and y 0.349. That selected the first value. Well, what about the next value? It's 5. And the next one is 0, so none of the trajectories were calculated because there was no point, because it probably selected either the first or second value from the array. Now, if we press enter again, we get a value this time. This time, it came off as 10, meaning it selected the third component from the array, and then we get that corresponding trajectory. We do that one more time, and we get the last value, which is 20 degrees. And 20 degrees is the last component of the array, and it corresponds to this coordinate. So there's a brief overview of how Unreal Engine can be used to make a function that selects at random without replacement. So hopefully that was a little bit informative, and if you fancy the challenge, I encourage you to check out Unreal Engine, and that's everything. Peace out, everybody, and take care.